Dear students, today we discuss about the frequency modulation. We know well that the frequency modulation is nothing but the frequency of the carrier wave varies with respect to amplitude of the modulating signal. This type of modulation is known as frequency modulation. It is the carrier wave, it is the modulating signal. During the modulation, the frequency of the carrier wave varies with respect to amplitude of the modulating signal. See here, the above figure is the frequency modulation. From the sine wave signal, where FM is the frequency and EM is the amplitude of the modulating signal. This is called a single wave. Here is called a single wave. The number of waves per second is called frequency. It is indicated by F suffix em. And then em cap. E is nothing but EMF. M is the modulating signal. So EMF of the voltage of the modulating signal is called em cap. It is the instantaneous value. So it is the maximum amplitude. It is maximum amplitude. It is minimum amplitude. So from this area to this area is called as EM cap. That is the amplitude voltage of the modulating signal. Same way, the carrier frequency also has the frequency Fc. The single wave is, this is the single wave from here to from this point to this, and then here this area to this area is called frequency Fc. This is a single wave. You know that the number of waves per second is called a frequency. The number of waves per second in the carrier wave is higher than the number of waves per second in the modulating signal. The amplitude EC cap, it is the maximum amplitude, it is the minimum amplitude. So this area is called EC cap. EC cap, it is the amplitude of carrier signal. After the frequency modulation process, the frequency of the carrier wave shifted to higher value when the amplitude is maximum. See here also, the frequency is shifted to maximum value when the amplitude is maximum. The frequency of the carrier wave shifted to lower value when the amplitude of the modulating signal is low. Here also, the amplitude of the modulating signal is low, so the frequency is shifted to lower value. So the maximum shift in frequency is known as frequency deviation. It is proportional to EM cap, and the frequency deviation del F is equal to kf by 2 pi into EM cap, where kf is the proportionality constant. It depends upon the characteristics of the circuit which used to generate frequency modulation. The general equation of an unmodulated carrier wave is given by E is equal to EC cap sin phi c of t, where phi c is the initial phase, total initial instantaneous phase, and it is given by omega c plus theta into t, where theta is the initial phase, phi c of t is the total instantaneous phase. So theta is the initial phase at the time t is equal to 0. The angular frequency omega c is given by, it is equal to d phi c of t by dt. The amplitude of the carrier remains unaltered during the modulation process. The amplitude of the modulating signal is given by Em is equal to Em cap cos omega mt. E is the EMF, that is the voltage. EM, the instantaneous angular velocity of the modulated wave is given by omega is d equal to d phi of t by dt. It is equal to omega c plus kf em cap cos omega mt. The total instantaneous phase of the frequency modulated wave is given by, on integrating this above equation, we have integral omega c plus kf em cap cos omega m of t. We will have the phi of t is equal to omega ct plus kf em cap cos omega mt by omega m plus theta naught. But theta naught is the initial phase and it is neglected because it plays no part in this modulation process. So the equation for the frequency modulated wave is given by E is equal to Ec cap sin phi of t. Substitute the value of phi of t, we will have this. This kf em cap by omega m is taken as a delta. The equation for the frequency modulated wave may be written with the use of Bessel function. You might have been studied the Bessel Legendre polynomials and Bessel functions in your first BSc Allied Mathematics. So it is written in the form of Bessel function. E is equal to Ec cap j naught del sin omega c of t plus Ec is equal to j1 del of sin omega c plus omega m of t minus sin omega c minus omega m of t, and plus Ec cap is equal to j2 of del sin omega c plus 2 omega mt plus sin omega c minus 2 omega m into t. Likewise, you know well that omega c is equal to 2 phi fc and omega m equal to 2 phi fm. So this expression is known as the spectrum of frequency modulated wave. It is consists of the component of the carrier frequency and the infinite series of side frequency components extends above and below the carrier by the amount equal to Fm. See here, it is omega c is nothing but 2 pi fc, omega m is nothing but 2 pi fm. So fc plus fm, here fc minus fm, here fc plus 2 fm, here fc minus 2 fm, here fc plus 3 fm, here fc minus 3 fm. So the side frequency band differing from carrier frequency by fc by fm called first order frequencies. It is called first order frequency. It is called first order frequency. Likewise, it is second order frequencies. It is third order frequencies. So this frequency modulated wave consists of the spectrum of frequencies with respect to the amplitude of modulating signal. This process is known as frequency modulated process.